Okay, I'll be working on the Chapter 5 review part 1. I'm going to do all of the odd problems. You should practice the even ones. 1, 3, and 5 are asking you to find the inverse of each function. So that's where we're going to write the steps of what's happening to the x value. So we kind of want to write the function steps, and then we want to write the steps of the inverse by reversing everything. And then we're going to write the inverse equation, okay? I'm actually going to copy that so I don't have to write it 3 times. We'll do it here, as well as here, okay? Okay, so what's happening to x? Well, you're multiplying by 3. And then we're subtracting 4, okay? If we reverse that and go from the bottom up and change the operation, we are going to add 4 and then divide by 3. And then we're going to take that green column and we're going to actually write the equation, which is what the answer is, what we want. And I start by putting an x, and I'm going to add 4 to it. So I put a plus 4. And I'm going to divide by 3, the whole thing by 3. And there's your answer. Number 3, what is happening to x? And when I say what is happening, if I plugged in a number, like if I put a 2 in there, what would I do first to that? Well, I would subtract 4. And then I would divide by 3. So we're going to reverse it and start from the bottom up. Instead of divide by 3, I'm going to multiply by 3. Instead of subtract 4, I'm going to add 4. And now we're going to take those green steps, and I'm going to write g to the negative 1 of x. Here's my x value. I'm going to multiply by 3, so I'm going to actually put it in front, and then add 4. And there's our answer for number 3. And number 5. Again, you're thinking, if I plugged in a number, if I put a 3 here, what would I do first? Well, first I would square it. Then, let me get rid of that so you can see it better. Then I would multiply by 2. Then I would subtract 5. So now again, we're starting from the bottom up. Instead of subtract 5, I'm going to add 5. Instead of multiply by 2, I'm going to divide by 2. And instead of square it, I'm going to square root it. So I'm going to write h to the negative 1 of x. And we've got 3 steps here. So there's my x. I'm going to add 5 to it. I'm going to divide by 2. And then I'm going to square root it. And you're square rooting the whole thing. And remember, when we have a square root symbol, we're going to add a plus minus to the front of it. And there we have number 5. Number 7 wants the same thing. Okay, we're going to find the inverse, but then we're going to sketch a graph of the original function and the inverse function. Okay, so first let's do our 3 kind of columns, the function, the inverse, and the inverse equation. Okay, so we're looking at 2x minus 1. And I'm actually going to multiply by 2 and then subtract 1. So reversing it and reversing the operation, we're going to add 1 and we're going to divide by 2. And then finally, we can write our equation. So here's my x. I'm going to add 1 and divide by 2. Okay, so we are going to graph this blue equation and the original. Now you're going to use your graphing calculator. I'm going to use Desmos just to make it a little simple when making this video. But y equals 2x minus 1. What you want to do is get the table of values. Okay, so you're going to go second graph. I'm just going to go to my table, and I'm going to plot like 3 of these. Okay, I'm going to get negative 1, negative 3. So let me make sure I'm on red here. Negative 1, negative 3. 0, negative 1, and 1, 1. Okay, so there's my 3 points. I'm going to label them in a second. Okay, so I've got 1, 1, 0, -1, and -1, -3. Now to draw the inverse, you don't need to graph it on your calculator. You just need to reverse the ordered pairs. So if I have 1, 1, 0, -1, and -1, -3, right, the inverse is going to be 1, 1, -1, 0, -3, -1. All I did was flip the x and the y. So let me plot those. 1, 1, -1, 0, and -3, -1. And here's this line. Okay. Now I know that these are inverses because of a very important detail. If you draw the line of symmetry, which is basically the line that cuts right through the origin, it's called y equals x. I'm going to write that in, line of symmetry. Okay, y equals x. It will actually be the folding point of the two graphs. If you folded that piece of paper on that line, the red and the blue graph would match up identically. All right, here's another graph. They already have the function graphed. We just want to graph the inverse. Okay, so first of all, let me talk about this graph. This is a parabola, and it's actually a function. Now, what makes it a function? Let me explain. If you take a vertical line, I'm going to draw a vertical line. See that vertical line? If you take that and the graph only hits at one point, it's a function. So anytime I draw it, it's hitting at one point. If I'm right here, the graph only hits the green line one time. If it hits it multiple times, then it's not a function, but this is a function. Okay, so now with that said, here are the original points we have, right? There's quite a few of them. We'll list them all because we can't really graph it without listing all the points. So, -2, 5, -1, 0, 0, -3, 1, -4, 2, -3, 3, 0, and 4, 5. Okay, so that's our function. I'm going to make it a little tinier. Move it over. Now, I'm going to tell the inverse ordered pairs, and all I'm going to do is flip the x and the y. I'm not changing any sign. So instead of -2, 5, it's 5, -2. 0, -1, -3, 0. The signs are the same. It's just the order that I wrote them in. 0, 3, and 5, 4. Okay, now I'm going to plot this one. So I've got 5. Actually, I'm going to use another color. I'm going to use purple here. But 5, -2, 0, -1, -3, 0, -4, 1, -3, 2, 0, 3, and 5, 4. And we get this kind of sideways parabola, right? And now if you're thinking about this, and if I ask the question, is this a function? Only think of the purple graph right now. If I draw a line right here, isn't it hitting here and here at the same time? That's not a function. If I draw a line right here, here and here at the same time, it's no good. Here and here. Okay, so that's not a function. The original one was, and now this one, because it turned on its side, it isn't. You're going to do the same thing with number 10. Make sure you list your ordered pairs so that you can plot the opposite, the switch of the x and y. Okay. For these problems, I'm only going to do the odds here, remember. But remember we had kind of our like generic formula. And if the log problem looks like this, you would say that b to the x equals m. You have to memorize this. So you're looking that this goes here. This becomes the exponent, and it equals that kind of regular, that number there, or that variable. Okay, so number 11, we're going to have 2 to the question mark equals 32. And you can put this on the calculator. We've done that in class. We'll practice it more again on Thursday. But the answer is 5. You will need to show the equation and then the answer, okay, on your test and quiz or test and team test. Number 13, the equation would be 5 to the question mark equals root 5. If you did put this into the calculator, or remember that I talked about the square root, the answer is actually 1/2 or 0.5. So our answer. Number 15. Okay, the question mark is moved now. That's okay. It's still the same setup. 3 to the 3 equals question mark, not a 3. Too many 3's. So what is 3 to the 3rd? Well, that's 27. Again, you cannot just go right to the answer. There'll be a line on there that asks for the equation. Number 17. 6 to the question mark equals 216. You can put that in the calculator. If you remember, it's under math. And then you're going to go down to option A. And you're just going to hit enter. And you'll see kind of a setup with blank pieces on there. Okay. The answer is 3. And number 19, 4 to the negative 2 equals question mark. When you put it in the calculator, the actual answer is 1/16, but there is a decimal version of it. Let me find that for you. 4 to the negative 2, 0.0625. Either one is fine. Okay. All right, that is it for part 1. I will have the next video for part 2.